Okay, we start the discussion of this exercise by first looking at one example, and we're going to go back to the first questions and talk about some properties and try to prove those properties. Now the fundamental theorem calculus says that if we know the antiderivative to a small f, then all we need to do is to calculate this integral is to just replace the value of x by b and subtract fa. Now big F here is the antiderivative of a small f. Okay, this is a very elegant theorem. So I'm going to do just do part A and look at how we may apply this theorem to calculate whatever is required here. The area actually between this function and the x-axis. So okay, now first we need to find antiderivative. Clearly fx is x cubed, is its antiderivative is big F x equals to x to the power of 3 plus 1 over 3 plus 1. Now why do we know this? Because there's a table of antiderivative, and if the small f, one of this according to a table, one of this result is big F x here. It will be xn plus 1 divided by n plus 1. So we're using this table directly, and so the n in our example is 3. So 3 plus 1, which clear, and we have this, and so therefore the integral, the area basically is a to b. In our case, it's actually 0 to 1, and it's x cubed dx. We know our antiderivative now is this big F, and so that means we're talking about f1 minus f0 must follow the order where you put the 1 and 0. So you start with 1 and then end with 0, and we know this is actually x to the power 4. So 1 to the power 4 divided by 4 minus 0 to the power 4 divided by 4, and the outcome is 1 over 4. Since we're talking about area is a unit square, you can check your calculation using a calculator like this. Okay, and so you turn on and then find this key if you could. Enter this power 3, and it goes from 0 to 1. So the area, for this case, is 1 over 4. Okay, it's as simple as that. Now let me return to the first questions. The reason is I want to prove this some of these properties, not all, just perhaps the first one. I'll try the numbers. C is the third one. So okay, this is a fundamental theorem. Again, let me cite this. Again, big F is the antiderivative of a small f. So if you think about it, this is actually formula to calculate area under curve. We will have a chance to talk about this later. So let's show the first property by using the fundamental theorem. So okay, this is a fx dx. Now what we're going to do is we're going to assume that the big F, assume a big F be the antiderivative. We do not know what that is, the exact function. It's not important. So let's assume that big F is the antiderivative of the small f function. Okay, and so it means that this is fa minus fa, and it's going to be 0. So this is shown. Now if they ask you to explain the result, it's very clear. From a to a, this is the area function. A to a is going to be a strip. Suppose this when you sketch this, you get a function. So fx, this is strip a, and from a to a there's no width, this strip, and so therefore area is 0. So this is what does the result mean? Actually the area is actually 0. Let's try C. How about this? How do we show this? We just use the fundamental theorem again, and according to the fundamental theorem, this fa, remember we follow the order where we put this two parameters, or these two values. So since we started with a, so we write a fa first and then subtract fb and we can do this. Obviously they are just values, but what is this within brackets? Well, if you look up here, this is basically that is the integral of a to b small f dx, and the negative, do not forget that, and then you have shown this